Okay, I wanted to take just a couple of minutes to talk about simple circular curves. There's a section in the book, chapter 24, that talks about them pretty extensively. And since we're employing them in our alignment, I just wanted to kind of define a few things. And then when you see them in the program, Civil 3D, it'll make a little more sense. So this is a simple little diagram. And if you remember correctly, we started off with tangents. The tangents are the straight lines that we started with, and then what we ended up doing was fitting a curve to those straight lines. So I just want to kind of go over what this diagram is showing. Maybe not everything, but the real important things. Obviously, one of the most important things is the radius. And so the radius for our curves does not change. It stays constant. That's why it's called a simple circular curve. These points here, the PC, the PI, and the PT, those stand for point of curvature, point of intersection, and point of tangency. Interesting thing to realize is the length of the curve is the length measured along the curve, okay? And this is kind of an important one here too. This is called the central angle of the curve, okay? So there's a lot of interesting geometry here, but I just want to go over the basics. This straight line connecting the point of curvature to the point of tangency is called the long chord. The distance from the point of curvature to the point of intersection is the same as the distance from the point of tangency to the point of intersection, and those distances are called the tangent length. One other thing that's, we'll see it if you look closely in the program, is there's something called degree of curvature. And there's a couple definitions for the degree of curvature, but most commonly, the degree of curvature is, you could think of it as the angle subtended by 100 feet of arc. So if this was 100 feet from here to here measured along the arc, then the degree of curvature would be this angle right here. Okay, so sometimes that's a little confusing for people. But the thing you should see is that the degree of curvature gets smaller as the radius gets larger. They're inversely related. So just wanted to go over a few of those things. The PC, point of curvature, PT, point of tangency, where those two tangents intersect is called the point of intersection. The central angle is this angle down here, like at the bottom here. Notice that the central angle also appears here. And then the degree of curvature. We won't worry about the middle ordinate and the external. The length of the curve is actually the distance measured along the curve. Remember that when we defined our curve, we simply used the radius, okay? The tangents were already drawn. That means the central angle is known, and we used the radius. So when you define a curve, you need at least two things, like the radius and the central angle, or the long chord length and the tangent length. Any two will define a curve, okay? Thank you.
Okay, everybody, I just wanted to shoot out one more video here. Last time we created an alignment, and if you remember correctly, we started off with 4 tangents, and those tangents they looked something like this. Whoops. That was supposed to be a straight line, but anyway, our tangents look something like that. And then we fit these circular curves to it, and we use the objects that we had drawn to define our alignment. Now, I just talked a little bit about curve parameters and some of the terminology here. Again, you can see that our alignment starts with a straight line, and then here's our point of curvature, and here is our point of tangency for the first curve. Of course, these are the stationing of these points, and the length of the curve is the length from the PC to the PT measured along the curve. Also notice that Civil 3D does put a little marker in here at the PI. You can snap to that, by the way. You might not have noticed that. So anyway, we've got this alignment defined, and we started at station 10 plus 0, 0, and we ended up, if you did everything I asked you to do, you should have finished with station 16 plus 15.14. Okay, now if I want to just take a minute here to look at some information about the alignment. By the way, notice over here that in our tool space area, we see evidence of that alignment being right here, alignment number 1, I called it. Now, if I left click on my alignment here, and then I go to the geometry editor right here, and I'm just going to show you this alignment grid view. If I click on that, here's a lot of information about the alignment. You can see that it starts with a line, and then a curve, and then a line, and another curve, line, curve, line. That's all it is. And then over here we have the length of each one of those entities right here. Here's the length. Here's the radius of the 3 curves. First 2 were 100, second one was 50. Only the lines have a direction, so here's the direction of all the lines. And then over here we have the stationing. Here's our starting station, 10 plus 0, 0, and here's our ending station, 16 plus 15.14. Now, I did mention to you the delta angle is the angle, the overall angle of the curve. And then the degree of curvature is the angle subtended by 100 feet of arc. And so, that's kind of a way of describing the sharpness of the curve. So I just wanted to show you guys this. You can take a look at that if you want. Now we have an alignment and we have a surface. So next week we'll kind of be finishing up with creating a profile. And if you look at the syllabus that I gave you guys at the beginning of the semester, we will have covered every subject, I think. So, please plan on wrapping up next week sometime. We're going to take this alignment and marry it to that surface and generate a profile which will show elevation on the vertical axis and stationing along the horizontal axis. So I think we'll finish up next week with that, and then I'm going to ask you guys to email me your drawings. And hopefully you'll have all these different things, a surface, an alignment, a profile. Okay, so have a good weekend.